All right. So we are currently in our unit motion slash forces, and we know that motion is when an object's position changes over time. You guys know how to calculate speed, and in fact, you know how to calculate distance and time if given the other information as well. You know that velocity is exactly like speed, but it has direction with it. And if velocity changes in any way, you have acceleration. So it's more than just speeding up. Go ahead, Caleb. It's slowing down or changing direction as well. Okay. So now, last week we interpreted some graphs. We did some graph review. We want to add this to our notes now. Okay. I'm going to quickly show you a few graphs. I would draw those in your notes. If you're using, I see some of you going to your digital notebook right now. You can verbalize the notes now or take screenshots as we're going through this as well. Okay. Your water bottles and the eggs, we're going to do that activity after our break. So I'll get to that after we talk about graphing. Okay, so the first graph I want to talk about is your position versus time graph. Okay, so in your notes, I would just draw this basic shape here. And I'm going to, in general, point out some features for you. Okay, if you are going straight to your digital notebook, which I see as some of you are, then I recommend that you type the generalities in here. So for instance, I want to look at this red arrow, okay? So I'm talking about this part of the graph where it's slanted upwards, okay? So go ahead, raise your hand. Who can explain to me what's happening to the object during this part of the graph here? Again, this is all participation points for the week, right? So if you raise your hand.
He's moving to the right. Oh.
Till I call on you, please, we can explain what's happening in this part of the graph here. Okay, so this is what we're going to do as we're going through here. So Matthew, what's the red arrow telling us?
The red arrow is telling us which part or which line.
Okay, and what's happening at this part, at this line?
He's going forward.
Okay.
Or there's yeah.
Okay, good. This is position versus time. So yes, the object is, or the object is moving forward, position versus time here. Now you guys are asking about the notes. Do we put this image in our notes? Yes. Now, if you're going straight to your digital notebook, it might be hard to grab this image right now, but remember after 5th period, these slides are going to be available for you, okay? If I'm doing my digital notebook right now, I'm not writing it by hand first, I want to add to my notes. When I would put big time, position versus time graph. Slant upward means object is moving forward. That's what I would put in my notes, okay? Then we have this green arrow. I'm gonna lower your hands. Who can help me? What's happening to the object in this area of the graph here? Armand, what's happening here?
The man is moving in the opposite direction.
Okay, so instead of forward, he's moving?
Backward.
He's moving backward. So here now, again, this is position versus time graph. He is moving backward in this situation, okay? Then we have our blue arrow. Marcus, can you help me with the blue arrow?
The blue arrow is it going at a constant speed to the right. I mean, no, a constant speed standing still.
Say it again.
The blue arrow is the object going at a constant speed standing still.
Okay, standing still, right? Because it's position versus time. So for this one, the object is standing still. The position is not changing for this one here. Now, if we were looking at a velocity versus time graph, this straight line would mean something else. Okay, so it's very important for us to know which graph we're actually looking at. Okay. Yes, Sahil. I recommend that you take notes by hand first. Research shows when you do that, you remember stuff a lot better. You could always take a picture of your notes and upload those to your digital notebook afterwards. Okay. Derek, go ahead and turn your camera off. Okay. Again, add colors, highlight, use bigger font, diagrams, all those things are good note-taking strategies, okay? All right, click go faster or go slower. All right, I have a few of you that click go slower, so I'm gonna give you 1 more minute and then we're gonna move on, okay? I'm gonna give you less than a minute. I'm gonna give you like 30 seconds, okay? So now our next graph is going to be velocity versus time. When we're talking about position versus time, we're simply looking at whether the object moved forward, moved backward, or stood still. Those are the 3 things a position versus time graph can tell us. We could do further calculations, but just by looking at the lines, that's what the lines are telling us. Okay, all right, so let's go to our next graph. Our next graph is velocity versus time. And when we have velocity versus time, I'll give you a moment to write this down. Again, make sure you know that you're talking about velocity and time for this graph. So the first feature I want to point out is this straight line here. So raising your hand, what is this red arrow pointing to? What's happening to this object here? Brianna, what's this red line telling us?
It's telling us that it's going at a constant speed. It's going at a constant speed.
Perfect, right? Because now it's velocity. Straight line means it's going at a constant speed. It just so happens, and I wish I didn't do this, that I put it at 0, meaning the object is not even moving. But I do want to point out that if this straight line were anywhere else, like Brianna said, it's at a constant speed or a constant velocity for this one here, okay? Again, I regret putting it on the 0 or on the origin because technically it means it's not moving. But that straight line for a velocity versus time graph means it has constant velocity, okay? I'm gonna clear your hands. Marcus, was that a question or were you want to volunteer for the next one?
It was a question.
Okay.
So since you said you didn't want to put it on the origin, will we write it as not being on the origin?
That's up to
Or
you.
will we write it? Okay.
That's up to you. You can write it off the origin and make sure that you know it's a constant velocity, or you can do both. This is a constant velocity. It's just a constant velocity of 0, which means it's not moving. So, all right. So now we have the blue arrow. Velocity versus time. Who wants to share what this is telling us on the graph here. Angel, what's the blue arrow telling us?
The object is moving forward.
Say it again.
The object is moving forward.
Okay. Anybody else have thoughts? Armand, what do you think?
The object is increasing speed.
Okay. Any other thoughts? Okay. So this is where position versus time. Oh, Brianna, what would you like to add?
That the object is going faster or increasing speed.
Okay. So when it comes to velocity versus time, when the graph is going up, that's going to be the velocity is increasing or it's getting faster. So this is where it's important. This is different from position versus time. Now we will talk about changing direction in a little bit, okay? So this is also getting faster over here, okay? So there's two places in this graph where the object is getting faster or increasing its velocity. Then we have this green arrow. Let me clear the hands again. Who can help me with the green arrow? What is the object doing here? Philemon, what's the green arrow tell us?
It means that he's getting slower.
Okay, so here the object is getting slower or decreasing. And it's actually happening in two spots here as well with the arrow going down. Okay. Notice we haven't addressed whether or not the guy is going forward or backward yet. Because when it comes to velocity versus time, the way we know something's going forward or backward is where it is on the graph. So if it's above the origin, that means this object is moving forward. So this moving man here was going faster moving forward and then slowed down moving forward. Then if it goes below the origin, drops down here, now it's moving backwards. Now this guy turned around, started slowing down, going backwards, and then sped up going backwards. And then right here, he turned around and went forward again. So right here, the origin separates whether the object is going forward or backward for that one there. Okay. Questions on velocity versus time. All right, we have one more graph and then we're gonna take our break, okay? Go slower or go faster? Matthew, is that a question?
Yes. What if you know how you said if it's above the origin, it's going forward?
Yep.
What if it's on the origin? Or it's just not moving?
Okay, yep. If it's on the origin, it's not moving. It's going
Okay.
0 meters per second. Good question.
Okay, thank you.
Mm-hmm. Very good, Matthew. All right, let's talk about acceleration and then we're gonna take our break, okay? So now, slightly different again, acceleration versus time. Okay. There's a reason why these glasses only cost $10. Because they're all wonky. All right. These are, look, it just broke. How sad. Okay. Anyhow, just like the velocity versus time, if you're above the origin, you're moving forward. If you are below the origin, you're moving backward. But then this would be different, Matthew, because if I'm at the origin, I'm not accelerating. So I am not getting faster or slower. I'm staying constant. Okay. So it's a little bit different. So let's take a look here. Let's look at the red arrows. So they're all going up. Raising your hand, what does this mean for the object? Again, this is acceleration versus time. What would the red arrows mean? I'll slow down. I think I'm going too fast. Sahil, what do the red arrows mean?
It means that the object is either increasing or decreasing in speed or changing direction.
Okay, so, right, you brought up 3 ways. Changing direction is going to be whether it's above or below the origin. Now, do you think the angle going up means it is speeding up or slowing down?
Speeding up.
It's speeding up. Very good. Okay. So I put a lot of words in this little box. I don't want you to write down all the words. Only write down the bold part. Okay. So the man is increasing in velocity. It's getting faster. I put a lot of extra words in here because I wanted to address the moving man activity. Some of you were getting really frustrated with the moving man activity for the acceleration, because what this means is that he's getting faster and faster and faster and faster and faster every second. And I was playing with this yesterday, and what happens is the moving man runs out of space. So he's going faster and faster and faster, and he hits the edge of the pathway, and then he stops. So then it drops down like a dramatic plummet drop, and then it goes back to 0 and it stays at 0 because then he's no longer accelerating. I was getting emails, this is glitchy, it's not working. No, it was working just fine. But unfortunately, you only had so much space for the moving man to move, and he couldn't keep up with that big. Notice how small it is. But it was such a big difference that he ran out of space. Armand, do you have a question?
What I did was I just removed the 2 barriers on each side, so the man had like a free way to walk off screen. So that made it easier. It didn't have that plummeting drop.
Oh, that makes sense. I didn't know you could do that. So you took away this brick wall? Oh, I see a little X on there. Smart. Well, thank you. I didn't know we could do that. So what would these blue arrows mean then? Let me lower your hands. What would the blue arrows then mean for this one here? Angel, what did the blue arrows mean?
The man is decreasing in velocity.
Very good. So here, again, there's a lot of words in this little box I'm going to show you. Just do the bolded ones. So the man is decreasing in velocity now. But just like mentioned before, if you didn't remove that barrier like Armand did, then he ran out of space. I'm going to write that down because now I need to tell my futures. Remove the barrier.
I have a question.
Yes.
And, even after I remove the barriers and even with the trackpad, it doesn't really work. So then I pulled out a mouse. Even when I pulled out the mouse and started increasing the speed, it would still spike up and down. I moved it as smoothly as I could, and it would still go 0, like completely didn't follow it.
So the moment you stop going faster and faster and faster and faster and faster, and let's say you stay at a constant speed, it's going to drop. It's very, very sensitive. It wants, in order for you to keep that incline going up, you have to go faster and faster and faster and faster. And then slower and slower and slower and slower and slower.
Yeah, I did that, but I guess it's the twitching of your hand.
Yep, the moment you pause for a split second, then it says, oh, we're not accelerating anymore, and it'll move back up to the origin that way. So good job pushing through the frustrations for that one there. Okay. All right, other questions? All right, we're gonna take a break. Before we take our break though, we're gonna gather our materials for our activity. Now, we found if you have the frozen water bottle and the non-frozen water bottle, still use it. But we found it doesn't work quite as good as a hard-boiled egg or the plastic egg. So if you happen to have some eggs, grab them. If not, and you have your frozen bottles, that's okay. We'll make it work as best as we can, okay? So let's go ahead, let's take a break. I'm gonna pause recording, make sure, okay. I'm gonna be demoing the eggs, plus I have a video at the end, because my demo doesn't do it much, the video's better, let's just say it that way, okay? And if you don't have supplies to try this on your own, then you can do this another, like tomorrow or whenever somebody goes grocery shopping, you can just try this out on your own because it's kind of cool, okay? So before we do that though, we are going to, we have a little engage. I have some videos to show you. So go ahead and open back up or have that Go formative. It's the same one as your warm-up. And we're gonna be looking at the first set of questions for the engage. So we're looking at number 2, 3, 4, and 5. So that first section that says engage, that's what we are gonna be looking at, okay? So, here we go. I'll show you over here on the video. So on the formative, we're looking at this engage. So what is happening to the crash dummies between wearing a seatbelt and not, and then plates, okay? So I'm gonna play it once first. I just want you to watch the video first, and then I'm gonna go back and replay it for you so that you can answer those questions. So don't worry about the questions right now, just enjoy the video as is, okay? Oh, wrong one. Here we All right, so we're gonna rewatch that, but now I'm gonna give you time to actually answer those questions. So the first part, and Aditya, do you have a question, Adi? No? Okay. So what is happening to the crash dummies, and what was the difference between wearing a seatbelt versus not? So let me rewind, and I'm gonna pause it on just the crash test dummies. Ready? Here we go. What's happening to them, and seatbelt versus no seatbelt. All right, go ahead and fill out your worksheet. I want to remind you or let you know that anytime we do an engage or an explore, there's really no wrong answers. So as long as it's logical, you are tell me that the flowers are pretty, okay? But what's happening to the dummies? That's number 2 on the formative. And then what's the difference between wearing a seatbelt versus not? Okay. So I see about half of you still need to get to number 2. I'm going to play it one more time in case you didn't get it. Oops, I didn't mean to do that. Okay. Yep, slow-mo. Okay. Good. I'm looking at your Go formative. Drew, you should be doing number 2. Izzy, you should be doing number 2. All right. Okay. So you got to keep up. You got to stay with us. Drew, are you still there? All right. So now let's go to number 4. Number 4, why do you think the plate/cup stayed on the table after the tablecloth was pulled out? 23 seconds. All right, so now you should be answering number 4. Drew, I left you a little comment in the chat box. All right, one more time and then we're going to move on. All right. There we go. So that was number 4. While I'm waiting for a few of you to catch up, any volunteers that want to share with us, first of all, the crash dummies? Seatbelt versus not, and then these plates and cups. I should have done that first. I apologize. So, Garika, which one would you like to share? What do you think?
I want to share the seatbelt, the crash dummies.
Okay,
So do we answer both 2 and 3?
sure.
So number 2, I put the airbags open and they were kind of flying forward. And for number 3, I put that if a person wears a seatbelt, the impact of a crash wouldn't be that bad. But if a person didn't wear their seatbelt, they would be injured very badly and possibly even dead.
Okay. Sahil, what would you like to talk about?
I'd like to do crash dummies, but if you want me to do the other one, I'm okay with that.
That's fine. Go ahead.
Okay, so when the crash dummies weren't wearing a seatbelt, they got launched forward, and then the people in the back got gut punched by the headrest in the front. And then after they got launched forward, the people went through the, what do you call it, windshield, and they were joining the people in ISS,
Okay,
International Space Station.
so here we go. Armand, can you talk about the plates for us?
I'm not sure about this, but I think that the plates remained on the table because the cloth was pulled at such a high speed that the plates remained where they were.
Okay. Anybody else want to talk about the plates or cups? I'm neither going to confirm or deny any of your ideas right now, okay? Derek, what do you think about the plates?
The cloth was moving too fast for the plates and cups to follow them, so they only moved a little bit and then stopped moving.
Okay. Anybody else want to talk about the plates? Sahil, what would you like to say about the plates? And then we'll move on.
Between the cloth and the bottom of the plate, there's not enough friction. So when you pull it down, it doesn't hold it tight enough, so it just slips by.
All right. Let's go ahead and watch the last one. So, question is, why didn't the eggs go flying? Here we go. All right, go ahead and answer. I hate that. Go ahead and answer number 5 now. Why didn't the eggs go flying when the tin pan was knocked out of the way? Izzy, I'm leaving you messages in the chat box. I need to know that you're still here. All right, I'm gonna play that one more time for you. Not the whole thing, just the egg part. Short and sweet. All right, and then lower your hands. Any volunteers to give us your thoughts of why this happened? Why didn't the eggs go flying? Again, there's no wrong answers right now. I'm neither going to confirm nor deny. Okay, let's see. Oh, Izzy, what do you think?
I think that the egg doesn't move because they're not hitting the egg, they're hitting under the egg.
Okay. Abigail, what do you think?
I think the eggs didn't go flying because when the pan was hit, the toilet paper tubes fell to the side or to its side, causing the egg to fall straight down.
Okay. And I've heard from you guys a lot already. Anybody else? New voices. I've already heard from you, sir. Thank you, though. Others. Alyssa, what do you think?
I think that the eggs didn't go flying when the tin pan went flying because the toilet paper roll was supporting it to go in the direction of the cup, and the man also hit the tin pan really quickly.
Okay, all right. So that's our engage. Now we're gonna get into our explore. So if you have a pair of eggs, this is gonna work best. If you have water bottles, it'll work okay. If you have nothing, then I'm gonna need to change my, I'm gonna use my second device here to have this go. I'm gonna go ahead and mute myself and turn this off real quick on this side. And now I should be unmuted on this side. So go ahead. If you have a pair of eggs or a frozen bottle, change your view to a speaker view so that you can see my second device here. Okay. And bring this whole thing up. Okay. I have 2 eggs. I have a hard-boiled egg. I put the H on there. And I have a raw egg. If you have a frozen bottle and a non-frozen bottle, you're just gonna spin them, okay? So go ahead and start spinning them. If you don't have any materials, yep, go get your stuff, okay? Stop screen sharing.
Miss King, we can't do speaker view on this. Oh yeah. Okay.
Is that easier to see now? But now let me pin my video. Good. Pin this video. So I have my hard-boiled egg, I have my raw egg, and you're going to spin both of them, okay? And then we have the questions on the formative. We're looking at the explore part now. So numbers 6, 7, and 8. Why did the objects move? Do both objects move the same? And then what happens when you gently tap it? So spin and then tap it to try to, okay? Spin, I don't know why. This, and then try to tap it. Oh. Okay. So let me, is it better this way? No, better this way. Okay. I'm gonna spin it again for you. And now I'm gonna spin the hard-boiled egg. Let me try to keep it in the middle. Spin and then tap it. Now I'm gonna spin the raw egg. And then I'm gonna tap it. Again, my demo is okay. The video I have for you is better. So go ahead and try that. Try that on your own a couple times. Let me now mute this one. And unmute over here. And turn this on and turn this off. Okay. So go ahead and try that. If you have frozen water bottle versus a non-frozen water bottle, it'll sort of work. If you have nothing and you couldn't really see my demo that well, then wait for the video. I have a video for you in just a moment here. Yep. Okay. Yes, you can. Don't tell your mom though. Playing with your food is science. Yep. All right, let me see where you're at. All right, I'm gonna go ahead and play. There's a brief video to explain what's going on here. And it's a lot easier to see what's going on. So if you didn't have any materials with you, pay attention to what's happening and you can answer 6, 7, and 8 even without materials right in front of you. Okay, here we go. Oh, I think I still have my volume.
Spin a boiled egg. Most people know that if you try to spin a boiled egg, it'll spin nicely. And when you try to spin a raw egg, it'll be a bit more wobbly. But there's a cool trick you can do where if you spin a raw egg and then you stop it, the raw egg will start spinning again. What's going on? Why does it keep spinning? Well, it's because of something pretty important to physics. which is called inertia. Inertia is the property that all objects have, which keeps them doing what they're doing. So when you get the egg spinning, the yolk inside is spinning as well. And if you stop it from the outside, if you stop the shell, the yolk keeps spinning inside. So it'll get the egg spinning again without you having to touch it. Whereas with a hard-boiled egg, because the thing is solid inside, because the egg is solid, as soon as you stop the shell, you stop the whole egg, and there is no more inertia to keep the egg spinning.
All right. I'm going to play that one more time. I should see you guys all answering 6, 7, and 8 now. Why did the objects move? Do they move the same? Explain. And then what happens when you gently tap the shell or tap them to stop them? Okay. Isabel, I left you another comment. I'm sorry, Izzy, another comment. And I'm going to send another comment here. And then Faith, I left you a little comment. Oh, there we go. Okay, I'm going to play it one more time in case you need to see it again.
Most people know that if you try to spin a boiled egg, it'll spin nicely. And when you try to spin a raw egg, it'll be a bit more wobbly. But there's a cool trick you can do where if you spin a raw egg and then you stop it, the raw egg will start spinning again. What's going on? Why does it keep spinning? Well, it's because of something pretty important to physics, which is called inertia. Inertia is the property that all objects have, which keeps them doing what they're doing. So when you get the egg spinning, the yolk inside is spinning as well. And if you stop it from the outside, if you stop the shell, the yolk keeps spinning inside. So it'll get the egg spinning again without you having to touch it. Whereas with a hard-boiled egg, because the thing is solid inside, because the egg is solid, as soon as you stop the shell, you stop the whole egg, and there is no more inertia to keep the egg spinning.
All right. It's time for us to take a break. You should be done on the formative 1 through 8 should be filled in by now. When we get back, we're going to finish 9, 10, and 11. I'm going to go ahead and pause my recording. What I need you to do is search. If you look at number 9, number 9 has you actually define or explain Newton's first law of motion. Make sure you cite. I had several students in first period use nasa.gov, which is a great resource, okay? Then what you're going to do is you need to find 2 examples of what Newton's laws actually is, okay? They could be images, they could be video clips to demonstrate your understanding of Newton's law, okay? Then explain. So you're gonna find out what Newton's first law is, find 2 examples, and then explain those examples, okay? What you don't finish will become your homework today, and this is due by 8 o'clock tonight. I'm gonna stop you. Ooh, we only got a couple minutes, so go ahead and do that. And I'm gonna stop you in about 5 minutes to show you my summary video, okay? So go ahead and spend the next couple minutes. And Izzy, I left you more comments, more chats. So again, this worksheet is going to be your 10 points synchronous classwork for the day. $240. So 244. Okay, in 2 more minutes, I'm going to start my summary video. All right, 1 more minute. Drew, are you still there? Faith, are you still there? All right, you guys need to keep working. I should see 7 through 11 being filled in.
So I inserted the image link.
Okay.
And it shows an image icon, but it doesn't show the image. So I don't know if on the teacher end it'll show an image.
Let me see. Number 10?
Yes.
I don't see it. So
Download it.
yeah, or remember when we went to the preview, image preview, you use the one on the right side instead of the little one on the left side?
What?
Hold on.
Image.
Yes, yes, Faith. So images, let's say. So when you're doing your images here, you know, notice if I click on this, then on the right side, the image pops up. If I copy image address from on the right side, that works better.
Oh, image address. I did link address. Okay.
Image address. Okay. That's okay, Garika. They'll be there. Okay, I need to start this last video because we are running out of time. Izzy, I left you more comments.
Newton's first law of inertia states that an object stays in motion with the same speed and direction unless acted on by an external force. Normally, a car and its occupants move around at the same speed, but when an external force is applied to the car, in this case by the crash test block, the occupants continue to move forward at the same speed until a force is applied to them. This resistance to a change in motion is called inertia, and it applies even when the velocity is 0. It's this property that enables people to do things like this. The china on the table stays pretty much at rest, even when the tablecloth's pulled from under it. That's because there's not enough sideways frictional force to overcome the china's inertia and get it to move. Back to the crash test. Because they're not wearing seatbelts, inertia means the occupants of this car continue travelling forwards until the windscreen applies the force to stop them.
Let's look at the inertia here. You can see the vehicle coming forward, it's stopping, but the occupants carry on because there's nothing stopping them carry on. That's the basic Newton's law here. So you can see the occupants, because they're unrestrained, the driver has hit the steering wheel and the whole steering column is crushed around him. You can see he's partially ejected and would be severely injured. The poor passenger, even though he was in the back of the car, protected by the front seat, because he's not restrained, he goes through the front seat and he's gone through the windshield, and you can see his head still sticking out there.
Of course, in real life, you get a lot less time to regret not doing up your seatbelt. Newton's first law gives us the idea that in a car crash, things keep going until something stops them. First used in the 1950s, seatbelts provide an external force that counteracts the passenger's inertia, bringing them to a halt in a more controlled way. But they're just one of the ways car designers reduce the forces on the occupants in the event of a crash. And every car designer also needs to understand the principle behind Newton's second law of motion.
All right, so you have your Go Formative is due today by 8 o'clock. If you need more time to find some examples, you have it. Make sure you hit submit and then click down on Google Classroom when you are all done, okay? Izzy, if you could please hang out for a little bit. Otherwise, everybody else, I will see you on Thursday. No, I'll see you in my homeroom. I will see you on Thursday. Yes, number 7. Yes. You can just not really explain, but describe how are they different, Evan. Okay. What do you mean redo unit tests, Sahil?
Derek Randall asked, no wait, not Derek, Samuel asked when the digital notebooks are due.
Oh, got it. All right.
When is the new one due? Or is the date there? Like the notes we took today.
You guys will submit once a month.
Oh.
So a month from last Wednesday.
And to redo, we just unsubmit, fix it up, and then
Yep.
resubmit.
And resubmit it. Okay. All right, Izzy, do you have any questions? Because I'm noticing that you only did the first one. Actually, you didn't even do the first one. Do you guys mind exiting, please, so I can talk to Izzy alone? Thank you. I'll see you guys Wednesday. All right, Izzy. So what's going on, girl?
I've just been having what's it called connection issues, but my parents have been helping me like write down stuff like on the side.
Okay, but you should be able to do some of the work as
I am.
you are, because on the formative right now, I can show you what I can see. There's nothing for you.
Well, I know, it's just what's it called. It's hard for me because then it slows down my stuff.
Okay, well, if you have a second device, you could do the formative on a second device. But even if it goes slow, you still need to stay with us on the formative, because it's telling me, because even in previous days, you haven't done your classwork either. And this is going to kill your grade. This is part of you actually staying and participating and working during class. Okay, because we can't do what we did in the spring and just sit here. We have to actually work during class time. Okay, so even if it's lagging, I still expect you to get the work done during class. Do you understand? Okay, so because when I look up here, I can look at view responses and I look at period 3 totals and I can see everybody. And notice here, Izzy, you are the only one not doing the work. Everybody else see all these gray spots? They all have been doing the work. And so it worries me that this person's absent today. You're the only one, and this isn't the first time you've done this. You have to do the work during class. Okay? Okay, so, and if you have questions, so I was very glad that you actually participated this week. Like, so you're gonna get your 5 points, but now this assignment is worth 10 points for today's work. So we need both. We need you to raise your hand like you did today, which was awesome, but now we have to add in the classwork as well. Okay? All right, let me know if you have any questions, and you have until 8 o'clock tonight to finish this. Okay, have a good day. I'll see you on Wednesday. Bye.